Hi, today we are going to learn about sorting. So let's know what is sorting. First, in programming, suppose we have collection of elements, like it may be collection of numbers or collection of some separate data type. Suppose we have collection of numbers. The numbers are 9, 4, 2, 1 and 0. So here we can see that these numbers are in random order. So like if we want to sort this number, the sorting can be of two types, like it can be ascending or it can be descending. So suppose we wanna sort this array in ascending order, so it would be like it would start from low and go till high. So if we sort this in ascending, the array would look like 0, 1, 2, 4 and 9. So sorting means making a group of elements into an ascending order or a descending order, like it would be an increasing or decreasing order. It has many real world application of sorting. Suppose one application that I can show you about sorting is, suppose if we go on any online shopping website, suppose Amazon, and I search for smartphones. So it gives a list of smartphones, but assume that my budget is too low, so I want that the smartphones which are cheaper should show first. So here we have an option of sort by. Suppose here I do sort by low to high, it would show the smartphones of lowest price and then it would gradually increase the price. So this is the sorting. So now let's learn the sorting and implement it by ourselves. So in programming, we normally, when we are building an application, we use inbuilt sorting functions that are provided by the programming language. Suppose in Java, C++ or Python or any other programming language have their inbuilt sorting methods. But for learning purpose, today we are going to implement our own sorting method. We will write the code for sorting by ourselves. So there are many algorithms that we can use to sort the array. So these algorithms are like insertion sort, merge sort. Let me move this thing. Merge sort, quick sort, bubble sort and many more. But these algorithms have their own flaws and benefits. Suppose like merge sort and quick sort are way faster than many other algorithms, but their flaw is they are little complicated to implement. But whereas sorting algorithms like insertion sort and bubble sort can be implemented very easily, they are not very complex. But the thing is, they are slow algorithms, like they take much more time than merge sort to sort an array. So now let's learn one algorithm. Let's learn how bubble sort is implemented. So let's see what is bubble sort. Suppose we have the same array. Let me write the array. uh, Suppose we have elements 9, 4, 2, 1 and 0. Let's take this -1. Okay, so how does this bubble sort works? What bubble sort does is, at a time it takes two element and compares them. So first it would take 9 and 4 and compare both of them. So is 9 greater than 4? Yes, it is. So if the current element is greater than the next one, it would swap the position. So 4 will come here, 9 will go there. So we have done the comparison of 9 and 4. Now we will compare the next two elements, 9 and 2. Is 9 greater? Yes, it is. So we will again swap. Now 9 and -1. Is 9 greater? Yes, it is. So we will again swap. So -2 will come here and 9 will go here. Now we will compare 9 and 0. Is 9 greater? Yes. So we will again swap. 0 will come here, 9 will go there. So we have done one iteration of bubble sort, and what we observed, 9 came to its proper place. Like we saw that in this array 9 is the greatest element, so it should be at last, so it came at last. That's why we call this algorithm as bubble sort. It means the greatest element will bubble up to the last position. It means it to its correct position. So in first iteration we got 9 at correct position. Now let's reiterate it. We will compare this to 4 and 2. Is 4 greater? Yes. So we will swap. we will compare these two. Is 4 greater? Yes, we will again swap. Now we will compare these two. Is 4 greater? Yes, we will swap. Now 9 and 4 are at correct position. Let's do it again. So we will compare 2 and minus 1. Is 2 greater? Yes. So we will swap. Now we will compare the next two. Is 2 greater? Yes, it's still greater than 0. So we will swap. Now 2, 4 and 9 are its correct position. We are not sure about the position of minus 1 and 0. Like we can see that they are in correct position. But if the numbers were different, by algorithm couldn't see. So we have to do 2 more iteration. So we will compare minus 1 and 0. Is minus 1 greater than 0? No. So we won't swap. So and one more iteration, we don't have anything to compare with. So we can see that this array is sorted. Let's write this into the code. Okay, so let me create a new file for implementing the bubble sort. Okay, so I'll right click here, new Java file. Let me erase this all thing. Okay, it's gone. New Java file. Let's name it as bubble sort. Okay, here's the main method. Suppose we have an array. Let's take the same array. It was, I guess, 9, 7, 3, minus 1 and 0, somewhat like this. And let's print the array after we have taken. Here's the array before sorting. Here we will implement our bubble sort, and once we have implemented the bubble sort algorithm, we will print the array again. So array after sorting. Okay, so now let's implement the algorithm. What we saw about the bubble sort, like after every iteration the biggest element comes to the last. So if the array size of array is 5, so how many iteration we have to do? 5 iteration. And in every iteration we have to loop through every element of the array and compare these two position. So what we can observe by this, there will be two for loop. First for loop will be for every iteration, like there are n elements, so there would be n iterations. And the second inner for loop, there would be one inner for loop also. This inner for loop will compare two elements at a time, and if the first one is bigger, it would swap the position. So let's write the code for it. So let's write the bigger for loop. For int I equals to 0, I should be less. We will iterate to the size of array, array dot length I plus plus. And now the inner for loop, j equals to 0, j should be less than array dot length j plus plus. So at a time we will compare two elements of the array. So like suppose in this array we were comparing 9 and 7 at a time. So if the position of 9 is 0, what would be the position of 7? It would be 0 plus 1. If we want to compare 3 and minus 1, the position of 3 is 2. So what would be the position of minus 1? It would be 2 plus 1. Suppose for any element the position is j, what would be the next element? The next element would be j plus 1. So this way we will compare. If array of j is greater than array of j plus 1, it means that the current one is greater than the next one. In this case we have to swap, so we will swap. So let's see how we are going to swap. There are many approaches to swap a variable. We will take the traditional approach of a temporary variable. So let's create a temp variable. In temp equals to array of j equals to array of j plus 1, array of j plus 1 equals to temp. So we have swapped the position. So now let's run the algorithm. uh, there's a little error in this code. I would request you to pause the video and figure it by yourself. It's a little catchy, little tricky, but still, let's see. I'll run it, and here's the thing: the program crashes. What it says, like, array index out of bound exception. It's saying that index 5 is out of bound. Like, if we index this array, so the indexes are 0, 1, 2, 3, 4. The last index is 4, and the error message is saying somewhere it is accessing the index 5, which is not present. That's why it's saying index 5 out of bound. So let's see where this issue is happening. If you observe the inner for loop, it's starting from 0 and going all the way till the length of array. Like, it's starting from 9 and it's going till the last position, that is 0. So what we are doing is, when we are at the 0 position, what we are going to compare, we will compare 0 with 0 plus with the next element. Is there any element after this 0? No, there is no element. That's why it's giving index out of bound. So to handle this, we have to go only till the second last element, that is this -1. So we will make changes in the inner loop like this. And if I rerun the program, let's see the output. Okay, actually this is the array before sorting, it was the way it is, and this is array after sorting. Let's clean this code a little bit to make it look prettier. Println, and after every element is not printed on new line. Like, here we can see every element was being printed on new line, so we will print the array on same line. Let's run it again. Here you can see first the array was 9, 7, 3, -1 and 0. After we sorted it, it's in correct order. -1 is the smallest, so it's first, and the 9 is greatest, it's in the last position. So thank you. I hope you understand the bubble sort algorithm. If you have any doubts, please let me know. Thank you.